Today's mastermind session is leveraging data analytics to accelerate discovery. We've got a great group of people assembled. My name is Brice from Seven Bridges. I'm our Chief Revenue Officer, and I think this is, I think I've lost count as far as the number of Festival of Genomics events that I've attended around the world. But delighted to be on the virtual version of this versus live and in person in London as we were last year. So looking forward to the discussion. Let's start off with actually having folks introduce themselves that are on the panel. Adrian, would you start off?
Yes, I'm Adrian Carr. I'm a data science team leader at Kymab. Kymab is a therapeutic antibody company based in Cambridge, UK. That's me. Thank you. Julie?
Yeah, I'm Julie Gill. I'm the Associate Director of Bioinformatics at Gadeta. We are a small biotech company located in Utrecht, the Netherlands. We make engineered T-cell products, and we have a trial starting at Dana-Farber with our first therapy for multiple myeloma.
Vivek?
I'm Vivek Iyer. I run the Human Genetics Informatics team at the Wellcome Sanger Institute. And Sanger shouldn't need no introduction, but it's a large genomic research institute in the UK.
Thank you. It's like asking somebody if they know who the Broad is. Pete, you're up.
I'm Peter Clapham. I also work at the Sanger Institute. I'm responsible for looking after a team that specializes in supporting and delivering scientific compute solutions to our informaticians groups.
Vlad?
Hello, I'm Vladimir. I'm an informatics team leader at the Sanger Institute, and I take care of the cellular genetics program at the Sanger.
Thank you. Brice?
Hi, my name is Brice Sarver. I'm on the population analytics team under computational sciences at Janssen R&D, which is Johnson & Johnson's pharmaceutical arm. Our remit is primarily discovery using large population scale data sets.
And Katya?
Hi, I'm Katya Nevedomskaya. I'm a bioinformatics scientist at Bayer Pharmaceuticals based in Berlin in Germany. I'm working mostly in early research in oncology.
Thank you. And last but definitely not least, Atanas, I think I've known you the longest of everybody on this call.
Hi, everybody. Atanas Kamburov is my name. I'm a colleague of Katya's in biomedical data science in Bayer in Berlin, and also responsible for target discovery, biomarker discovery, and other things involving NGS as well.
Thank you. So let's start off with the first topic, which is around the utilization of cloud-based solutions for data storage. And along with that, the concept of actually how do you manage data in a cloud-based environment, or really any environment. Many of the organizations that we've encountered over the past 10 plus years that we've been in this space have struggled with not only losing data in the cloud, but how do you organize it? How do you make it findable? How do you actually conceptually bring it forward in what is now known as a fair environment so that actually it can be utilized to drive forward research on a global basis with organizations such as yourselves? And just so folks understand who we have on the call, it really ranges from small organizations such as Gadeta, who have really started their journey with data in the cloud, to larger organizations that are very HPC-centric, but moving to the cloud. So we have the entire gamut of folks on their journey to using cloud-based infrastructures, but not ignoring the actual use of on-premise utilization of existing and expanding high-performance computing environments within data centers, as has historically been done with organizations such as Sanger as well as Bayer. So with that said, Julie, if you wouldn't mind starting the conversation.
Yeah, sure. Thank you, Bruce. So as Bruce mentioned, we are really sort of at the beginning of bioinformatics at Gadeta. The bioinformatics has been at our company for only 2 years. And so we really started with a sort of a clean slate, I think. Unlike, I think, most of the other panelists who have larger companies and a sort of existing system before cloud became popular, we could just start from the beginning. And found most important as a small startup company is flexibility. We don't necessarily know what we're going to be doing 6 months ago. We have a good idea of what we'll be doing 1 quarter from now, but things can change and we need the flexibility. So for us, we absolutely wanted to go with cloud as just for the flexibility it offers, both for the storage and for the compute, so that we can invest when we need to at the time, and then we can sort of shut it down if we don't need to invest in the computing power or in the storage at that moment. And as well, we also do have some in-house systems on premise for storage and some compute power, but we really rely on the cloud to give us that flexibility to do what we need to do that we aren't expecting.
So Julie, just a quick question. As a smaller organization, and as you mentioned, you're starting your first trial with an entity that's on the other side of the world, here in the US. How are you handling security, compliance, and things along those lines, given that you're running in a cloud-based infrastructure?
Yeah, so we've actually just started addressing this, and I guess it comes as no surprise that we use 7 Bridges Genomics. So I think that's what really attracted to us, and sort of the compliance that is built in. So essentially, we're trying to outsource as much compliance as we can and not do it in-house. So we want to use the experts, and that's sort of our strategy.
Okay, thank you. So Brice, you've recently joined. You've been at J&J, I think, or Janssen, I should say, for about a year at this point. You're used to working in multiple different types of environments, including on-prem, cloud, as well as hybrid approaches, as well as supercomputing infrastructure with San Diego Supercomputing Center. Can you talk a little bit about the complexities of that and the challenges of managing data in that type of environment where you've got bits and pieces scattered all over to the 4 winds?
Yeah, sure. So I think it's a really interesting time to be thinking about these types of big data and big compute questions, primarily because we're talking about moving from this world where we have a small amount of data, maybe a small number of experiments or data generated for a relatively small number of individuals, all the way up to these biobank scale data sets, hundreds of thousands of individuals, whole genome sequencing, structural variants, proteomics, all the kind of gamut across the board of what we're working with. Now, it's interesting thinking about this with respect to looking back at the past, because many institutions will have taken a little bit of time, and if you're large and if you have the capital, you would really invested in that on-prem data center. You'll have a lot of bare metal with a lot of activation energy and lots of cost and capital expenditure up front in order to build out this great infrastructure. And nowadays, we're talking about data that are being generated or want to be served to the world, and those data don't necessarily live in a particular data center behind lock and key. The guiding FAIR principles that you mentioned earlier really want us to find ways to distribute those data to the world, and in order to bring in multiple data sets from multiple different sources in order to really leverage the full potential of those data, generally speaking. So it's interesting to think about this with respect to the kind of the divorce between the cloud-based solutions and on-prem solutions for this. If data are housed in a centralized location, whether that be on S3 or whether that be in a HPC data center somewhere, the real question around that is, how do we get the compute in proximity to the data such that the scientists can actually perform the work that they want to do on those data? So if it's in the cloud, we have a number of considerations that might end up taking place. If there's already pipelines and infrastructure built, there's a big logistical hurdle that really has to take place with not only the security and compliance aspects of it, but just purely the logistics of moving out, hundreds of terabytes, possibly petabytes of data from point A to point B. And we know if you've worked in cloud solutions before that there is a cost for storage at rest, there's a cost for egress, and thinking about how to make this type of movement once and only when it's mission critical is really something that's pretty important to think about. The second aspect of that really has to do around kind of backup and how we think about governing the access control in general. So it might be the case that cloud will work really well for particular sets of solutions, but this egress might be kind of a big hurdle for thinking about how we would want to scale up particular analysis, which might actually be done cheaper or already have workflows optimized in a particular environment. And so in that case, can we leverage kind of a hybrid cloud-based approach in order to utilize our large on-prem, physical storage media, while also pulling down the relevant pieces of information from different areas around the world? So the issue really has to do with really the size of the data. And I think when we are discussing these larger initiatives, the amount of data that has to move from point A to point B is going to be limited by cost, by the size of the throughput, by the availability, by, it might even be bottlenecked by a single point of internet connectivity to a particular institution. So I think all this has to come into play, and all needs to be kind of overshadowed or governed with a scientific mindset. What analyses do we want to do? Do we need to bring the data in proximity to compute? How would we do that? And then what's the best way to do that such that other individuals around the world aren't necessarily recapitulating the same analyses over and over again? Can we distribute those data back out, and what might that look like? I think cloud has a lot of benefits for that. And there's a lot of migration and movement and thinking toward these types of infrastructures as these solutions become more mature, and they're really nice platforms that help folks work with it. Not everybody needs to be a system administrator anymore. So I think this is kind of the way in which we're thinking in the future. There are going to be always dedicated use cases that are going to exist in any of these sectors, but I think finding the best fit for purpose is going to be one of the most important questions to think about when we're talking about data sets really of this size in the future.
Thank you. So Adrian, pivoting to you, Kymab's a little bit of a smaller organization. You're going to be going through a bit of a transition if the acquisition goes through and everybody becomes a part of a new organization. What do you see as the challenges, given that you've worked in the cloud, you have local infrastructure, local meaning centralized compute and storage, because a lot of this is maybe in transition as you migrate to a new organization, as well as, Brice, you mentioned something which is kind of interesting, which is the IT considerations and how that gets handled. And typically the IT rules and regulations and security requirements don't necessarily always align with the research needs, whereas researchers really need a little bit more flexibility or significantly more flexibility. So Adrian, if you wouldn't mind commenting on that and your perspective on that.
Yeah, I mean, Kymab's been around for approximately 10 years, and obviously most of our initial servers were on-prem, weren't really using cloud 10 years ago. So we've already been transitioning from on-premises to in the cloud over the last few years. As you mentioned, we've recently been sort of purchased, or that's sort of been announced that Sanofi is going to be purchasing this. And obviously that's going to be a challenge to integrate from our current system, our current relatively small system, to what is a much larger company, but will have systems in place. But I think a lot of the processes and a lot of the principles we're setting up at the moment should be sort of relatively agnostic in a sense, and should be able to fit into that system. In terms of data we generate, it's not huge compared with many other people. I mean, we're certainly doing quite a lot of NGS sequencing, but we're not talking petabytes of data. It's more terabytes, and a lot of it is more about knowledge management and actually keeping proper track of what the data is, how it was generated, linking our data, our sort of NGS raw data, to some actual experimental designs, how it was generated, and actually having that sort of proper limbs integration. It's not probably less of a volume issue and more of a complexity issue I think we're facing.
So thank you that's the perfect segue into volume and complexity, given the fact that we have Sanger on the line with us here. And all of those things factor into, because you guys do have a tremendous amount of volume of data as well as complexity of data, given all of the different programs and projects that you're involved in. So Vlad and Vivek, please, your researchers using these types of infrastructures, what are your thoughts on this?
Why don't we do good cop, bad cop? I can do bad cop first, and Vlad, you can follow up with good cop. Is that okay? Okay.
Yeah, please.
So at the moment, we have been, Sanger is a very heterogeneous institution, and I think that, we don't have, at the moment, we don't have a sort of an institute-wide posture about cloud adoption, and you'll see that in this duet. So I think from the human genetics side, we have very high volume sets, and a heterogeneous and sort of a heterogeneous compute environment, and what the advent of cloud delivery of genomic services, for want of a better term, has actually sort of done is to sort of increase the complexity of the possible solutions that we actually need to sort of adopt and sort of refine and work out if they're good for us. So in a sense, it's actually made things worse because I actually have to think more. Having said that, we see the same advantages to a cloud-based platform that everybody else does. I mean, the elasticity. Honestly, from the data point of view, the data governance point of view, it's hugely attractive because there's this giant economic kind of force which forces people to be quite efficient and watch their data use carefully. That's part one. And part two, I can notionally tag every item that anybody ever touches with metadata. I mean, there are sort of tools in place to do that, and tools in place to query that stuff based on metadata as well. At least, the baseline tools are there, even if the sort of the better applications aren't written on top of them. So it's very attractive. But what it's done is increase the complexity of the landscape. It's increased the palette, by an order of magnitude of the sort of tools I can choose. It's not just on-prem cloud. It's on-prem. Is it this cloud provider, that cloud provider, that cloud provider? And what doesn't really help is that many biobanks have actually chosen. They've almost like spread themselves out across the cloud providers, right? So if you want to interact with different biobanks, you actually have to have multiple relationships. And you can just get used to GCP and suddenly somebody else jumps for AWS or somebody else jumps for Azure. So, it's increased the complexity. So that's the bad cop. Maybe Vlad can follow up with the good cop routine.
Thank you. So my opinion on that topic is actually, I agree with Brice, mostly that it has to come, like the strategy should come from the user demand. So if users, customers, let's say, wants us to move the data to the cloud to share it with someone, then we probably should start looking into that and consider it. If not, and we have a nice on-premise infrastructure, I don't see the point of doing that. So I think, it all depends on the use case here. And again, for small companies who just start their journey, it's probably the easiest option. Go to the cloud, don't buy anything on premise, you don't need to support it. You're happy and you can analyze everything there. So for Sangha, it's obviously with petabytes of data that we have, it's not feasible, first of all, logistically, as Brice said, but also I personally don't see a lot of demand of that. So what we started doing, for example, in our program, we started trying to analyze the data on the cloud, but not store the data on the cloud. So we kind of upload the data there, analyze it, download, get the results without the need to upload the whole big data set there. So yeah, that's my opinion on that.
Okay, thank you. So Pete, pivoting to you, you've got multiple different masters at Sanger. How do you handle the complexities of data management given kind of what your two colleagues have outlined, as well as the myriad of other investigators that are constantly tapping you for different capabilities?
So you're absolutely right. As Vivek and Vlad have highlighted, we have very different user bases, very different questions that people are looking to address and to answer. And the tools are very different. And the storage mechanisms are dictated by the tools we use. But there are some common issues for everybody. The first one really is discoverability of data, finding my data. Where is my data? It's the first question. You put something in a sequencing system, dude, where's my data is the first question someone would ask. So querying data sets, not just on your own site inside your own data lake, but across the world. How do I know what data sets are actually available? If I'm a clinician, I want to know what data is out there that I can compare and contrast with. It's the first challenge is finding stuff out there. So this is where things like GA4GH are obviously trying to lead the way. They're trying to develop these areas, same as Orca in the US. So these common standards to make data more discoverable is the first part. There are then questions on how do I access that data? Well, I found it, but how do I get it? How do you get access to that data? Do you categorize the data and then you apply for it? Well, that's pretty burdensome. It can take years sometimes to get access to data sets, at which point your money's gone. So how do we accelerate that? How do we make this stuff generally useful to everybody? Well, there are proposals, perhaps to license the researcher rather than the data. It's Cat1 data, you're licensed to access Cat1 data, you're an environment that can support it. Maybe that's an approach. And these are the questions that are coming through in the entire ecosystem. How do we make data searchable? And we look at, say, commercial entities. I mean, how many people haven't used certain tools, such as, say, iTunes when you go home, or Netflix? Well, there's metadata on everything. People who watch this also like the following. Have you considered these options? There seems to be so many opportunities out there that are available that we have yet to perhaps develop to and enhance our ecosystems. Because fundamentally, when you wind up the £400 data gorilla, as was being described earlier, you've got these huge data sets. They're not just going to go somewhere else. You're going to have to bring the compute to that data set at some point. And one of the things we're seeing worldwide are projects such as COVID, at the moment, very, very poignant time for us all. You get huge step change in data acquisition. You get huge step change in the type of analysis people suddenly need to perform. The tools aren't always written. So where we look at cloud, there are opportunities for flexibility. It's a great place to do a quick test. Does this work? What do I need to do? Can I develop this with other people? However, the platforms are often limited by the performance of the storage layers, which of course are dictated by the needs of the applications we provide. So there are more questions to these hybrid solutions. And what we often see is an oversimplification. Well, it costs me $10 an hour to run it on site, $20 an hour to run it in another site. Hang on, they're 4 times faster than us. Maybe it's still cheaper to go there. But the cloud may be half the price of everyone, but during the times of peak load, it may take 6 weeks to deliver as opposed to 1 week on site. So there are a whole number of different metrics we need to consider and balance out, and actually kind of coming up with these data brokers and these work scheduling brokers. If we can improve transparency as to what the costs really are for a given workflow, that's got a huge benefit.
So thanks, and actually, your commentary is timely because one of the questions that just came in is as follows, which is, what would the panel like to see in the future from data and analytical platforms that is currently not possible? So kind of what does the wish list look like? What's the nirvana situation where people can actually access data? I'll use the word seamlessly. And, just curious, anybody that wants to chime in, Atanas, Katya, anybody else on the panel that might have their ideas of what the future could look like that you don't have now?
Yeah, I'll be happy to address that. But I think, Katya, you as well? I'll go after you.
Thanks. I actually wanted to mention, it was mentioned before about different cloud providers. And I think we in our organization are moving to the cloud very strongly, but obviously there has been a choice for a particular provider to run our compute powers. But the question is, with the data available on different providers, it's not always easy to plug it in. So for me, one missing point for the future is an easier access to different clouds, even if you have compute power with a particular provider, to be able to use the volumes from elsewhere. I think that would be very important, because obviously one cannot have access to every single provider. That's just not feasible with the same security obligations. So I think that's going to be very important for us as well. Atanas, please.
Yeah, I can just support this point. This would have been also my point, that also, as previously mentioned by Vivek, we have all these providers, and how do we kind of make sure that there is a layer on top of those that enables easy not caring so much about where the data are actually, which provider and what location of the provider. And the other point, of course, is standards for workflows, which it seems like every platform has their own standards, and they're all open standards, but I think we as a community should make sure they're translatable and they are supported by more than one provider.
So can I ask, Atanas, what do you mean by standards? Can I just ask what you mean by standards for workflows? I mean, I would have guessed that if you're using a workflow engine and it's got an API that drives Google and it drives AWS, and so that's your standard, right? The language in which you code up the workflow engine is the standard, and you just sort of count on the relevant provider to implement whatever the workflow engine is actually sending at it.
Yeah, I do mean the workflow languages like CWL, the common workflow language, which I think was initiated by 7 Bridges. There is WDL, there is Nextflow, and most of the engines. So, for example, Toil supports CWL, Cromwell supports WDL, but the support of the other languages is either lacking or problematic, so not fully supported. It seems like you have a different opinion, Vivek, on this.
Oh, okay. I mean, there's a mental overhead. It's a very pragmatic point of view. So, we've actually had feet in Nextflow. So basically, that's domain-specific language, for want of a better term, right? and Woodle, that's the Cromwell-based thing. I came away from CWL simply because the mental overhead of actually trying to, investing energy, you invest energy in actually any one of these things. And that one, the CWL, was by far and away the most high mental overhead of anything and with the least reward. Okay. So I was talking to somebody at a pharma a few weeks ago, and he was saying, yeah, we moved everything to CWL, all the workloads are described this way. And I was like, this is terrific. How did you get over the activation? And he said, oh, I don't think about that. I have a team in Poland that does all of that stuff, right? So I don't do CWL myself. I'm a strong proponent. I was thinking, it's a nice work. We should all be so lucky to have a team in Poland that sort of sorts all that out for us. And so, the mom and pop shop, Sanger is big, but, the teams themselves are relatively small. And we can't afford to hire the team in Poland, right? So I'm saying it's an expensive choice.
So I will support Vivek here. I'm a big fan of Nextflow as well. So my recommendation is Nextflow.
I think
well, we're not going to take a vote on. I'm sorry, Kat.
No, sorry, I'm going to delay. I was just going to say I agree with everything that's been said. There's no but to it. There are so many standards to choose from, right? The key part that we've seen from groups that have had particularly collaborative projects where they have to engage with multiple sites, it's not just the lowest common denominator, but picking solutions that you can use on multiple platforms, so you don't have to recode everything. So whichever one you choose, you could stick with. And as long as we have collaborations that take advantage of that cross-platform basis, then generally we find that porting from one platform to another is trivial. We do have collaborators that give us CWL files, and our PhD students look after us and keep us busy. I like your idea of that team somewhere else to look after that for me. And WDL, again, is another language, and we get the whole lot coming through the door. So we're not in a position to dictate it's one language and one language only for the Institute at this time, because the worldwide nature of it. But at least if we stick to these platform agnostic tools, go for common APIs wherever we can, then we reduce our coding language base and we reduce the impact upon our teams.
Okay. So I want to pivot slightly back to the data question, because a lot of the organizations that are on this call, as well as smaller organizations, use a variety of different, both publicly available data sets, such as TCGA, ICGC, that require a certain amount of registration and access request processes. And then there are also public data sets that are coming to the research community, but are restricted currently, but ultimately will be available. So when you look at things like FinGen and UK Biobank and Genome Institute of Singapore and French 2025, all of those different data sets are going to raise the level of complexity as far as the research utility associated with it. And they really can't be moved around, number one, economically. Brice, to your point, you can't move petabytes of data, and in many cases, these are petabyte-sized data sets. But also, they can't be moved geographically because of laws associated with genomic data and phenotypic data remaining in country and not leaving the four walls, metaphorically, of a particular location. Thoughts about that? How are you planning on handling it, given the myriad of different mechanisms you access data, how you access data now? Brice, you want to start off?
Sorry, I was muted. Yeah, I think that's a really good question. So I think there are really two sides of this coin. The first side goes back to discovery, that findability of the data. Do the data exist internally? Have there been dbGaP applications? Has somebody gone through this, laborious process to scope out a research project, get it approved, download the data, store the data, make it findable within the particular, infrastructure, metadata management, all that kind of stuff. And then the second part of it is really how we're thinking about this moving forward. So you're exactly right. This issue of moving around a lot of data that I mentioned earlier is really something that we've been thinking a lot about, and we're only going to expect these data sets to frankly get larger. So the question is, what does that look like? And I think one of the really interesting things that you brought up here is what do we do with these types of restricted data sets that might be locked down, and in the most extreme cases might be locked down, say, by particular governments or particular countries. They might not want a single bit of that data to be egressed out of any of their on-prem hardware, or cloud-based solutions where the hardware is housed within the country, for example. And they might not want summary statistics even to move around. So that's kind of up for debate. I think people are still trying to figure this out. So the issue is, well, that's fine. If you want to restrict the data to that degree, that's great. But what does that look like when we're thinking about this from a global perspective? Do these types of bigger initiatives need to think, really critically about implementing a platform or an analytical workflow solution or series of APIs, maybe leverage one of these workflow languages of choice or whatever the solution ultimately is. And I think we're right at the cusp of that, where these issues are now starting to come up as we think about these larger efforts and these big restricted data sets, that now is the time to actually put a little bit of thought into this and think about, well, what does it mean? Do we need to access, the data in this particular country? What can we actually do? Can we scope this out? Do we need to log into a platform? Do they need to harden their infrastructure? Do they need to manage all the security? And do they need to be very, very clear about what the use cases of those data are, such that they're not moved out? Because if somebody like Johnson & Johnson, for example, we might want to very well leverage a large variety of data sets across the world, from TCGA, dbGaP, any of these large biobank efforts. But we're also thinking about meta-analyses. And meta-analyses require bringing data in proximity to one another. And that's going to be a big, I think, hurdle moving forward. Is that going to be allowable? And will these institutions with more kind of restrictive access permissions, will they be working to integrate with these other large data sets such that we can perform those analyses, increase our power, increase the sample size of those analyses moving forward? I think this is handled better at some places than others, but I do think it's something that's going to be at the forefront of thinking about this type of data analysis over the next few years as these initiatives scale up.
So do you see that developing as a set of best practices? It's one of the questions that has come in, and I can only imagine the complexity of doing a meta-analysis for an organization like J&J, but also, are there researchers such as within the Sanger or within Bayer or Julian, some of your early discovery processes, are you trying to do meta-analyses against large data sets that are geographically dispersed? And, what are some of the things that you're thinking about? Because it is difficult. It is, they're stored differently in different locations, different ways, and at different levels of granularity. So how do you actually work through all of those complexities? Sorry, I threw it out there. It didn't point to anybody. So, Atanas, do you want to comment on that, and then anybody from the Sanger and Julie?
Yeah, I'm happy to start off answering these questions. So, for us at Bayer, I think we're mostly focused on analyzing our own data sets, and of course, the cloud infrastructure does allow for such meta-analysis, which of course then are limited by geographic limitations and so on. It is not a problem that we're facing. So I was just thinking, I was actually curious to hear about other organizations if such a meta-analysis would be business critical or would be very important to carry out, but is really hampered by these geographic constraints.
And so a lot of this comes down to being able to harmonize the data. So, Vivek, what are your thoughts on how to handle harmonization of these disparate data sets? Because the content's different, the way it's cataloged is different. How are you thinking about that?
Well, it's not a solved problem, right? And I think that the distribution. So the discussion so far made me think of a few things. Firstly, there's a method to doing this. Firstly, you need to establish a scientific necessity to do this, right? So it might be that your actual science doesn't need you to actually harmonize your set against the other set, even if you actually want to use the other set to inform the analysis of your set. So you need to establish that's scientifically necessary. But if that's true, then you need to either push your data up or bring their data down. And Sanger has traditionally worked by bringing everybody else's data down. Whether that's it's 100 terabytes, 200 terabytes, 300 terabytes, those sorts of things have actually come down, and they've actually, so TCGA, that kind of data has actually come down typically for analysis within Sanger. This trend is reversing, but it hasn't actually finished. That reversal hasn't actually finished, right? The pendulum hasn't swung. So we're faced for the first time with data sets that are so large that it is not practical just to suck everything down every time the data set increases its iteration. That's one thing. But secondly, the data set has been mentioned, may not allow you to pull it down, right? So GEL, definitely you work with GEL on GEL's terms. With UKB, of course, we did pull it down the last iteration, but I don't think that's going to be feasible anymore. We'll work with UK Biobank on their terms going forwards. So this sort of simultaneously, you have both the fact that these data sets are not local, they're actually in different places, in different non-local places. Okay, and you have to sort of cooperate and operate with them on their terms. You have to push the data up and work on their terms. So I guess we face a few different problems there. One of them is a simple technical issue: how to push it up and how to actually do the work in a remote space. And the method in one remote space is different to the method in the other remote space. That's one thing. The second thing, of course, is that for us specifically, the data that we want to push up is often subject to legal and ethical restrictions about where it can lie. So our Sanger data is subject to legal and ethical restrictions. And every time we have a different remote space, we have to go through a different set of contortions to actually push it up. And the legal effort at Sanger, anyway, seems to be, I'm probably making a wild oversimplification here, but it's focused on actually setting up the contracts to bring data in. It's not focused at all on actually where the analysis is actually going to lie and the agreements about whether we can actually push it back out again. Does that make sense? So it's the focus and the attention, all the attention is actually is ingestion and not on what happens downstream and the consequences of what happened downstream. So actually getting the lawyer's attention is actually really tough. And it's sort of messing up every discussion has a technical aspect and a legal aspect, and the legal aspect is it's messing up the technical stuff. It's messing up our ability to operate in the technical sphere.
Yeah, the legal folks always get in the way of good science and good research.
It's very necessary. I think it's this question of, what we're lacking is actually the person power to actually focus the attention there, right? And the lawyers there are not enough lawyers to keep track of all of that. We seem to be under-resourced that way.
And they also don't understand the research needs to the level of depth that is required so they can actually respond with the proper policies and procedures that actually enable the research to take place versus inadvertently restricting it.
But the understanding is a good point. I mean, there's definitely scope for a lawyer that actually understands the difference between a cell line, the sequencing of the cell line, the variant calling of the sequencing of the cell line. I mean, as far and I've had these very comical conversations with extremely well-meaning lawyers that actually sort of conflate all of those in one lump, right? And so that's actually quite, there's some room for better understanding there in that direction as well.
Okay, so everybody on this call should go out and get their JD, and then you'll be wildly employable at other organizations or your own and have job security. So we talked about it, and we only have a couple minutes left here. We've talked about it with very large organizations, but I've got to believe that both Kymab and Gadeta are facing the same types of things, just at a smaller scale. But you do access these public data sets to kind of launch your research in order to generate your hypotheses.
Yeah, that's absolutely right. I mean, we're obviously utilizing these data sets, but I think we generally analyze our own data and then go out into the public domain, reanalyze or take pre-existing data sets from the public domain like TCGA, and then bring it back in and do sort of meta-analyses. I think it's not that common that we try and do a full integration at the statistical level. It would be a sort of two separate statistical analyses and then combine them together. But it is obviously a pain getting the data, and having it in some sort of reasonably harmonized form where things match up is a pain for everyone. Even the TCGA's harmonized data isn't that nice compared with what the individual cancer data sets were like. The whole process of harmonization tends to be lossy, and even with expert curators, you end up with a situation where information gets lost in that process and it becomes difficult to use. So I think the harmonization is a key thing moving forward, having sort of standards which are uniform across data sets for everyone, and that will make the process a lot easier.
Okay.
Yeah.
And your final thoughts?
Yep, I'll echo what we just heard, is that our primary interest is analyzing our own data, and we found that the sort of the administrative and sort of legal burdens of trying to get appropriate data sets were really appropriate sort of semi-public data sets were really too high for us. And it kind of spurred us to say, okay, we're going to generate our own data. And what do we really need? So in that way, harmonization hasn't been much of an issue. We just use what we can get as a test set, and then we really focus on our own data and doing the separate analysis at our stage.
Thank you for that perspective. And with that said, we have come to the end of our time. I appreciate everybody's participation today. It's been a delight having you all on the panel, and some really interesting commentary from a wide variety of organizations as well, from both the size as well as complexity perspective. So thank you so much, and have a good day, everyone.
Thank you.
Thanks
Thank
for
you.
Thank you.